Hello viewers, we're taking you through the story for A-level pure mathematics. And this video, we are going to go through the marking guide for U.A.C.E Uneb 2024 for math paper 1. So this video is suitable for students in senior 6 offering principal mathematics as part of their combination. So these are the papers we hope to upload in this month of August. So question 1 of section A said, a committee of 7 people is to be selected from 4 men and 6 women. If the committee must have at least 2 men, determine the total possible number of ways of selecting the committee. So we have 4 men and we have 6 women, but they want at least 2 men. At least 2 means men can be 2 or more, so 2 or 3 men or 4 men. When we get 2 men and want a total of 7, it means there will be 5 women. When there are 3 men, it means there will be 4 women. When there are 4, it means there will be 3 women, like that. So those are the possible combinations. So I shall come and say, at least 2 men means 2 men and 5 women, or 3 men and 4 women, or 4 men and 3 women. So in combination, it means that out of the 4 men, you need 2. That's why you get 4 combination 2. Then out of the 6, you need 5 women. Then for this line, we shall say, out of the 4 men, we need 3 women. Sorry, out of the 4 total, we need 3 men, which is here. And out of the total of 6 women, we need 4, which is here. Then this one, out of the 4 men, we need 4 men. And out of the 6 women, we shall need 3 women. Next is to use a calculator, because calculator has this symbol of C. So we shall say 4 combination 2 is 6, 6 combination 5 is 6, 4 combination 3 is 4, 6 combination 4 is 5, is 15, 4 combination 4 is 1, and 6 combination 3 is 20. So this multiplication is because of the and this addition is because of the word or. So when you do that, you shall come up with 116 ways, and that's what they wanted. So each bracket had a mark and also addition, then the final output. So like I've always told you, Uneb after every marking, they usually make a report, and that report contains 3 parts. They contain what the question required, the weakness or the candidates, or where the candidates found challenges, and the advice, so that the next year does not do the same mistakes. And like I've always told you before, if you are planning to sit Uneb for 2025 and you have not yet seen Uneb for 2024, then that is not okay. Personally, I call it academic suicide. So I encourage you to watch this video with care so that you don't make the same mistakes which were made in the previous year. So this question 1 required candidates to apply conditional combinations. The condition was that they should be at least 2 men. It was a popular question, meaning many attempted it. However, some candidates failed to interpret the question correctly. Advise that expose learners to concepts of permutation and combination, and I believe your teachers have done so. So question 2 says, a cylindrical can of capacity 1,000 centimeters cubed is made from a thin sheet of metal. The metal is open at the top and closed at the bottom. The radius of the bottom is x centimeters. find the value of x that will minimize the area of the sheet to be used. Minimize the area. So that means that the surface area, because this will be the cylinder, therefore the surface area, if I am to use, I think in O-level you covered what we call nets. If we unfold this, it will become like this, but also there's something at the bottom, because bottom is also closed, so meaning that we shall need another metal sheet to make this circular part like that. So that means that if I'm to get the total surface area, the upper part is open, so there's no metal sheet at the top. If I'm to get the total surface area, I'll need this area and also this area. This area has a same radius as this for this circle, so r, even here radius is r. Here, if this is h, even this will be h. Here, if this is r, this will be the circumference, which will be 2 pi r. But you should be keen, if there's any letter given in the question, you have to use it. So in this case, they give us that radius is x. What does that mean? It means that I no longer need to write r, I instead write x. Here, that means that this will become 2 pi x. So if there is any letter which is given in the question, don't use another letter. Maintain that letter. So radius will be maintained as x. So you'll come and say, volume, first of all, volume is 1,000. This volume helps us to get the relationship between the two variables, because height and radius will be varying for you to minimize the area. Now that I've got that, I can now come and get the area of the sheet. Area of the sheet is the same as total surface area of the cylinder, which results circular part and rectangular part. These are two variables. I have to eliminate one. So let me eliminate h by putting h here to give you this. Simplify. You realize that here pi can cancel and 1x can go away. This and this becomes 2,000. Then here this remains as it is. So now that I've got a in terms of one variable, which is x, I can differentiate. So differentiation is only after obtaining one variable. If there are two variables, for example, do you see this area? Let me see. Yeah, do you see this part here? Here I could not differentiate because there is this h and there is x, whereby both are variables. So I had to first eliminate one variable, and what results I could now differentiate to give me this. Now after differentiating, that is when you substitute. But the good thing here, they didn't give us this. Okay, we don't know the substitution yet, but we are going to get it because they said minimize the area. So minimizing means the first derivative is always equal to 0. So minimum and maximum, the condition is that first derivative is equal to 0. So when I equate it to 0, I'll be able to get the value of x. Cross multiply and then make x the subject. And that's what they wanted. So question analysis, the question required kindness to apply differentiation. So when you see the word minimum, that is differentiation. Now there's also some students want to use completing squares, but the completing squares occurs is used when there is a quadratic. So here it was not possible. As you can see, this is not quadratic. Then the weakness is that failure to find the surface area in terms of the given variable. So they're supposed to remember that surface area is equal to this rectangular part and also the circular part. That was a challenge to some students in that year. So teachers should use practical models to illustrate different shapes, and that is by using nets. I think in O level you covered nets, so they are still applicable even in A level. Question 3 says the equation of an ellipse is this. Determine the coordinates of the center of the ellipse and the eccentricity of the ellipse. So 1, we are supposed to complete squares. So I'm going to rearrange, put the x's alone and y's alone. So this one I'll complete squares and this I'll complete squares. To complete squares, the coefficient of the squared term should be 1. So I'm going to first factorize out 4 to give you this, and here factorize out 25 to give you this. So in this case, you realize that here the coefficient is positive 1, even here positive 1, so I can complete squares. Complete squares means x plus half of this coefficient, which is 1, everything squared, then minus 1 squared. Same applies to here, y minus half of this coefficient, which is 2, everything squared, minus 2 squared, which gives you 4. But there's also another 4 here, so it has to be brought there. That is completing squares. Next is to re-expand, and next is to remove the box bracket and you rearrange. So when I remove the box bracket, this becomes this, and this 4 with this gives you this, this and this gives you this, this with this gives you this, then there's that 4. So this one and this will cancel and remain with a negative 100, which can go this side to give you positive 100. So when I divide both throughout by 100, I'll come up with this as the equation of the ellipse. And I think you know that ellipse is always in the form this. So by comparison, it means that you see here there is capital X and here there is capital Y. So it means that here in this case, capital X has been replaced by small x plus 1, and capital Y has been replaced by small y minus 2. If it is in this form with capital letters, the ellipse will be in this form. We'll have a center at the origin. Here, 0, 0 will be the center of the ellipse. If it is capital X and capital Y, but now we have small x and small y, so we need to get the corresponding values for small x and small y by using this form expressions. So put here 0, get the value of x, put here 0, get the value of y, and that will be the center. So x is 0, then the value of small x is that, then also capital Y is 0, the value of small y is that, therefore the center will be negative 1, 2. Roman 2, they asked for eccentricity. Eccentricity, the formula is there in the logbook. So capital A squared is that, capital B squared is that. Now from this one, we need to get the corresponding values. So small a will now be equal to 24, small a squared. Then in this case, because these capital letters correspond to when the axes are capital X and capital Y, but the axes have changed to small x and small y, so then the values of A and B should also change. So now small b squared will now be equal to 6, therefore eccentricity can be given by this formula. Substitute for b squared, a squared to get the value of e squared. And that's what they wanted. So eccentricity is that, and it's a positive value. So analysis question required candidates to write the given equation as an ellipse in standard form by completing squares. It was not a popular question, meaning that very few candidates attempted the question. The challenge was failure to complete squares. So complete squares, you should know the trick behind completing squares. Then teachers should emphasize possible change of axes. Do you see this word? Change of axes. Because in the question there was small x, now I used the capital X, meaning that the axes had changed from capital X, capital Y to small x, small y. Then question 4 says, show that the integral of this with respect to x is equal to 1 over 6 ln 2. One thing you should realize that the denominator can be factorized. Difference of two squares to give you this, and because it can be factorized, it becomes partial fractions. So we're going to decompose it into partial fractions. So equating the numerator, we come up with that. Then you shall put different values. So if I want to make this 0, it means x is equal to -3. So putting it x equal to -3, I'll come up with, when the whole of this is 0, and putting -3 here, I'll come up with 6 here. So a is 1 over 6. What if I want to make the whole of this 0? It means x should be 3. So putting x equal to 3, I'll come up with that, whereby 3 here gives you 6b. Therefore, b is 1 over 6. And in the end, I can now quote the resulting partial fraction. After that, I can now easily integrate. So I'll come and say the integral of that will be the same as the integral of 1 over 6. I think you remember that 1 over 6. So integrating this gives me natural log 3 plus x. Integrating this will give me negative because of this minus. Negative ln 3 minus x. Then I substitute the limits. Begin with the upper limit here and here to give you this. Then lower limit here and here to give you this. Then this is 0, and this is the same as 4 over 2, ln 4 over 2. When I combine, I'll come up with this as the required answer. The question required candidates to apply partial fractions in simplifying the integration. It was a popular question, meaning it was attempted by many. However, some students failed to resolve into partial fractions. That is, factorizing was a challenge. Then failure to integrate, bring in the natural logarithms, was a challenge. Teachers should emphasize factorization of denominator and hence express into partial fractions. So if the denominator is easily factorizable, then you have to first split into partial fractions. Question 5 says the population of a country increases in a geometrical progression by 2.75% per annum. Calculate the number of years it will take for the population to double. So one, we know that every year it increases in a geometrical progression by this per annum. So in the first year it will be this plus this percent, which gives you that. Okay. In the second year it will be now, this is now the population after 1 year. So that population increase again by 2.75%. You'll come up with this. But you know that P1 is this. So bring in the P1 here to come up with this. So I think you see that now the GP is coming. P3 will now be P2 plus 2.75% of P2, which gives this, but P2 is this, so come and substitute like that. Now that we have the first three terms, we are sure that it is a GP. Therefore, Pn will be equal to this, because this is how the general term comes about. If this is 1, even here the power is 1. If this is 2, even here the power is 2. If this is 3, even here the power is 3. So the general term will be that if this is n, even here the power should be n, like that. Okay, now what do they want? They said calculate the number of years it will take for the population to double. So initially, if initially it was this, after how many years will it be 2p naught? That's what they want. So it means that here with Pn, you put there 2p naught and be able to get the value of n. So when the population is now twice the initial, now p naught, you realize that it cancels away. When it cancels, you'll come up with 2 equal to this. Now there you will need some logarithms or natural logarithms to get the value of n. So using logarithms, I'll put log base 10 on both sides and make n the subject. That will be 25.6 years. So here we don't round off because the decimal places mean also months. And that's what they wanted. So question required kindness to apply geometric progression for the nth term. Progression for the nth term. It was not a popular question. So one weakness was misinterpreting the question. It was not easy to. That is why you saw me beginning from finding out the first term, second term, and third term for me to come up with a general term. But ideally, even if you don't do that, as long as you know the nth term of a GP, you can easily do it. Because let me show you how. Because nth term of a GP is a r to power n. Okay, so what do? You are going to say the first term will be, I think you see here the first term is this, so it will be 1.0275 p naught times the common ratio. Common ratio is this, so that times the common ratio, which is this, to power what? To power n minus 1. Now, why did I use n minus 1 here? It is because when I multiply 1.0275 by 1.0275 to power n minus 1, rules of indices show that this can cancel with this negative minus 1 to remain with this. So even if you began by quoting the nth term of a GP, it will still be correct. I only chose this so that you understand how it comes about from first principles. So advice to teachers that you should teach various applications of series. So most students are used to the common ones of depositing every year, but that will not be the case always. Like this year, it didn't come, and what it came was an application of the nth term, not the sum. So question 6 says, show that this is equal to this. So here it means You can either begin from left hand side or right hand side, but I think you realize it is tricky to begin from this side, going this side, because this one has a few terms. So it is better to begin from left hand side and simplify and until you get what is on the right hand side. So when I code the left hand side, I will simplify by saying that this, because first of all here there is no double angle, there's nothing like 2x. So my work is to first remove the 2x. So cos 2x is the same as this, and cos 2x here is also the same as this. Now why are they different? It is because I want to eliminate the 1. For example, here, if I want to eliminate 1 and I use 2 cos squared x minus 1, this one will not go away, because when this is in a bracket of negative and I open bracket, this will become plus. So it will become 1 plus 1, which will not go away. Yet for me, I want to eliminate the 1. So what I did, I have to look for an identity which will help me to eliminate that 1. And that is expressing cos 2x in terms of sign. There, this can cancel. Even here, same applies to this down. This and this can cancel. So when that cancels, we remain with this. So you are going to realize that 2 is common. So it can cancel away. And also you realize that if I split the numerator, okay, here what I chose, I could split the numerator. When I split the numerator, I'm going to come up with this over this, and also this over this. So there you can see that this goes away, you remain with this, which is tan squared. This goes away, you remain with sine x. And that's what they wanted. So the question required candidates to change the double angle to appropriate. Do you see this word? Appropriate single angle. Appropriate means that get an identity which will eliminate the 1 because it is not needed. Weakness was failure to express the double angle into appropriate, because double angle for cos has like 3 identities. One which has both cos and sine, another one which has only sine, another one which has only cos. That's why we use the word appropriate. So the formulas are there in the logbook, so you have to be familiar with them. Question 7 says, the point C is this, divides the line joining points A and B in the ratio lambda to 3. Using vectors, find the values of A and lambda. So if C divides, it means that A to C, the ratio of SC to CB is equal to lambda to 3. So SC is equal to lambda over the total ratio times AB, which is this. That is ratio theorem. So substitute SC is the same as OC minus OA. This is there. Then AB is the same as OB minus OA. So when I equate the JOK complement, JOK, why do we say JOK and not I? Because if I begin by equating I'll get 2 unknowns. So I should begin with either JOK. That's what can give me 1 unknown. So here, if I choose this, I'll come up with 2 is equal to this times 2, which gives me that. So now I have succeeded in getting 1 unknown. Cross multiply, collect like terms, and get the value of lambda. After getting the value of lambda, I'll come and use now the I component. I component, I have a minus 1 is equal to lambda, which is now 2, divided by lambda, which is 2 plus 3, multiplied by 5. So there I'll be able to get the value of A, and that's what they wanted. So the question required kindness to use ratio theorem. Ratio theorem was a must. However, some kindness failed to equate the components of the vector. So you have to equate I component alone, j component alone, like that. So teachers should emphasize equal vectors in terms of components. So yeah, what they mean is that if a vector is maybe A, B, C, let's say, and is equal to D, E, F. Because they are equal, it means that A is equal to D, B is equal to E, and C is equal to F. That's the condition for equal vectors. So now we shall go to question 8, which says, find the area enclosed by the curve y equal to x squared and the line y equal to x from x equal to 0 to x equal to 1. So 1, the curve is that, and the line is that. So area will be got by subtraction. So area contained between two, curve and the line, or curve and the curve, you subtract. So here the subtraction, it is, we don't mind what you want to begin with, unless you first sketch. If you first sketch, then it will be easier, because you can know that it will be like this, and the line will be up, and the curve should be down. So ideally, the line, what is up is what should be the first here. So if I was to be very accurate, actually here, that's what I did. This first, followed by this. But even if you don't follow that, it is still okay. Because you get a negative, then you put magnitude to get the positive area. So substituting for y is this, and also integrating, substitute limits, and get the final answer. And that's what they wanted. So the question required kindness to determine area enclosed between two curves. Actually, it should be one curve and a line. The weakness was failure to identify the lower and upper boundaries of the required area. So teachers should guide learners to identify the area enclosed between two curves or between a curve and a line. So that was section A. Now we shall go to section B. So question 9 says, part A, express this in the form this, where r is a positive constant and alpha is an acute angle. Positive, r is positive, alpha is acute. That is now our formula. So this is equivalent to this. Expand this compound angle to give you this. Then you'll now, this equivalent sign means that I can now compare, cos here. So what is left here is 12. What is left is r cos alpha. Mean that r cos alpha is 12. Here sine. What is left is 16. What is left is r sine alpha. So r sine alpha is equal to 16. Divide the two, I'll be able to cancel the r and remain with alpha. So sine over cos is tan. Therefore, alpha is this. We choose the acute angle. Then square Pythagoras theory, r will be equal to square root of 12 squared plus 16 squared, which is 20. Therefore, the given expression will be equivalent to 20 cos in brackets theta minus 53.13. So that was part A. Part B says, hence find the maximum and minimum values of this expression and also solve this equation. So for maximum, I think you know cos is always positive 1. So you substitute where there is cos, you put the positive 1 to get the maximum value, and the minimum value you put negative 1. And that's what they wanted. Then solving, you realize that this one, they are similar to this. So you shall replace it with the expression you got in part A. Then bring this 20 this side. Then I can now use a calculator to get a cos 3 over 4 to give me that. Now, why did I stop there? It depends on the range given. Let me first see the range. The range is from 0 to 180. So when theta is from 0 to 180, you realize that here, sine is positive in the, cos is positive in the first and fourth. So the next angle will now be outside the range of 180. That's why you have to ignore. And you only get that as the answer. And that's what they wanted. So the question required candidates to use compound angles in our formula. Some students failed to express correctly the expansion of this, expanding using compound angle identities, but remember they are there in the logbook. Compound angle formula is there in the logbook. So now shall go to question 10. Question 10 part A says, given that the polynomial this is exactly divisible by this, find the value of p and hence solve the equation this. So exactly divisible means the remainder is 0. Meaning that therefore this is a factor implying that the root is x equal to 4. Now when I substitute 4 where there is x, it means I should get 0. So substitute 4 here, I should get 0. Simplify, I'll come up with the value of p as negative 12. Now when I put negative 12 here, I'll be able to get an equation in this form. When I get that equation, I can now, but the value of p is negative 12, so I'll come up with this as the equation. And they've told us to solve the equation. The good thing, I already know one of the roots. So what I need is to get the other two roots. Because it is cubic, I'll need some long division or synthetic division. So shall look at both, but let's begin with long division. Get the divisor and also the polynomial. Then divide by this, I'll come up with x squared. Now x squared multiplied by the whole of this, I'll come up with this. Subtract the 2, you will come up with this. Then again, 4x squared divided by x, you come up with 4x. Then this 4x multiplied by the whole of this, you come up with this. And when you subtract, you'll come up with that. Then again, this divided by this, you come up with 3. So 3 multiplied by this, you come up with that. Subtraction gives you 0. So that's up there. If I wanted to use synthetic division, I would first write the coefficients of x cubed, x squared, coefficient of x, and the constant. Then after that, I write my root here, x equal to 4. Here we write a factor, here we write a root. Then after that, bring this value here down. Then multiply 4 by this and put it here, which is 4. Add these ones to get 4. Then repeat the procedure, multiply this by this to get value put here, and then add this to give you 3. Repeat the procedure, this times this, you get what we put here, and add this, you get 0. So this last value, this means there's 0 remainder. And the quotient will be this. I think you'll see if you look at this and this, they're somehow similar. How? This is the quotient of x squared, coefficient of x, and the constant. So any of the two approaches is okay. So you have that, and when this is factorized, you get this. Therefore, the roots will be this, this, and that. And that's what they wanted. Then part B says solve the inequality, this one. So the first thing to do is to put everything on one side, then get LCM to combine into one quotient. So you have to expand and factorize, simplify and factorize, if any. So when we expand, collect like terms, this and this gives you this, this and this gives you this, then this remainder gives you negative 36. So factorize will come up with that. Therefore, critical values are each one is equal to 0. This equal to 0 gives you 9. This equal to 0 gives you negative 4. This equal to 0 gives you negative 3. So the table of signs, you begin here. You should know that we have written them in ascending order. So values before negative 5 are given by this inequality. So we can say maybe values before negative 4. So you can choose negative 5. Put negative 5 here, you get a negative. Put negative 5 here, you get a negative. Put negative 5 here, you get a negative. So in the end of it all, you come up with a negative. Values between negative 4 and negative 3 are given by that expression. We can choose now negative 3.5. Put negative 3.5 here, positive. Negative 3.5 here, negative. Negative 3.5 here, negative. And we end up with a positive. Then values between negative 3 and 9 are given by that inequality. We can choose 0, put 0 here, put 0 here, put 0 here, and you end up with that. Then values beyond 9 are given by that inequality. We can choose 10. So put 10 here, put 10 here, put 10 here, and the end will be positive. Therefore, the solution set will be this and this because they're the ones which are positive. Maybe you should note that we have there or equal to because here the question had or equal to. And that's what they wanted. So the question required them to use remainder theorem in part A and remainder factor theorem, and also to solve rational inequalities in part B. Weakness of kindness was failure to factorize the quotient. Factorizing was the challenge. Failure to obtain critical values. That was now in part B. Failure to identify the correct ranges, that is table of signs, and failure to solve the rational inequalities. So advise that teachers should emphasize the various applications of remainder and factor theorems, and also emphasize difference between linear and rational inequalities. For rational, everything should be on one side. Don't cross multiply. Question 11. Part A says using the substitution this, evaluate this. So you come and first write if sine is x is that, theta will be equal to arc sine x, and therefore dx d theta will be cos theta. implying that dx is equal to cos theta d theta. So I have to change a variable. Then I also need to change the limits. When x is 0, put here 0, arcsine 0 is 0. When x is 1, put here 1, arcsine 1 is pi over 2. We use radians. Then now I can come and change the variables. Substitute for x and dx. So where there is x, we put sine theta, and where there is dx, we put cos theta d theta. Now this one is the same as cos squared, but because of the square root, that's why it is just cos. Then that cos will cancel with this cos. You remain with this. So integrating 1 is theta. Integrating sine theta is negative cos theta. Then the limits are now 0 to pi over 2. Substitute the upper limit, you come up with this bracket. Lower limit, you come up with this bracket. And using a calculator, you come up with this as the answer. Because this cos 90 is 0, so it is this minus 0, which gives you just that. Here cos 0 is 1, so negative of negative 1 gives you positive 1. That was part A. Then part B says, given that y is equal to arcsine this, find y dx in terms of x. So take sine the other side to give me this. Then I can now differentiate. So differentiate with respect to x. Sine y gives you cos y dy dx. And this is the quotient. So quotient will give me, keep this constant is here, differentiate this, then minus, keep this constant, differentiate this, you get this, you get the whole of this. Divide by denominator squared to give you this. So I realize that some things are common. Let me see what is common. This bracket is common. So cos x is cos y is the same as 1 minus sine squared y, everything under square root. Then you have simplified to come up with that. Then now I can factorize. So I already know what sine y is. So when I square it, I'll come up with this. Then this side, this one are common, by this power is small. So it's what I pull out to give you this. Then inside I remain with this, with a power of 1, and here this cancels, you remain with only this. The minus should be maintained. Here, this side I'm trying to combine into one quotient to give you this by getting LCM, and here this and this cancels, will remain with 1, which is this. Then this one goes down to the negative power. When it goes down, it becomes a positive power. Then this is now same base, so you have to add the powers. For this side, this cancelled, remain with only positive 1 as the numerator. So here I realize that this cancels with this to remain with s1 over this. So dy dx will be equal to that. And that's what they wanted. So kindness were supposed to evaluate the definite integral using the given substitution. Given. Don't choose your own substitution when they give you a substitution to use. Then part B, they were supposed to differentiate the given inverse trig function. Weakness was failure to change into one variable and its corresponding limits. Changing variable and limits was a challenge. Failure to simplify the derivative in part B. So teachers should emphasize to students the use of given variable. Once they give you something to use as substitution, don't use your own. In other words, they have restricted you to a certain method or approach. Then teachers should emphasize to students to use Pythagorean identities. I think you saw me using it where there was cos y. I put there this square root of 1 minus cos squared y. So it was an identity from trig. Question 12. A curve is defined by the equation this, parametric equations that and that. A tangent to the curve at point B, xy, is parallel to the line this. Determine the coordinates of B. Okay. So one, I'm going to first differentiate to get the gradient. So this, differentiate this, you come up with this. Then also differentiate this, you come up with this. So by chain rule, I'll be able to get dy dx, which is the gradient of the tangent. And is this. So this is a gradient function, okay? But because that line, the gradient of the tangent at this point B, is parallel to this line, they should have the same gradient. So this line has a gradient of this. Meaning that I can now equate the gradient function to the gradient. So that point, we have that. This goes with this, so remain with this equal to this. Then value of t will be negative a third. When it is negative a third, I can get the value of x and also the value of y, and that will be the coordinate. Then part B. Part B says find the equation of the tangent at B. The good thing, I now know the gradient and I know the coordinate, so I can easily get the equation of the tangent. And that's what they wanted. So analysis, the question required candidates to differentiate parametric equations. It was not a popular question, so few attempted it. Weakness was failure to simplify the derivative. So teachers should emphasize the simplification of derivatives. So in differentiation, the final answer must be simplified, written in the simplest form. In integration, we don't mind, but differentiation, we mind. So question 13, part A says, use Maclaurin's theorem to expand ln 1 minus 2x in ascending powers of x as far as the term in x cubed. So let's begin with that. Fx will now be equal to this, meaning that f0 will be got by substituting 0 here to give it 0. When I differentiate fx, I get f prime x, and substitute to get f prime 0, which is negative 2. Differentiate f prime x to get f double prime x using product rule. Then you also substitute when x is 0 to give you that. Differentiate f double prime, you get f triple prime. Then substitute for x equal to 0. Therefore, Maclaurin's theorem can now be got from that formula. So substitute and simplify. So this is 0, this one is that, this one, and this one. and that's what they wanted. Then part B, using small changes, find the approximate value of tan 46 degrees correct to 3 decimal places. So tan 46 is close to tan 45, so it will be equal to 45 plus 1. Therefore, write x plus small change in y, y plus small change in y is equal to x plus small change in x. So by comparison, it means that this is equal to this, and also x is 45, and small change in x is 1 degree. So you have to convert them to radians. Tan x is this, implying that y is equal to this, so implying that y is 1. Differentiate that tan x to give you this, then you substitute to give you that. Then I can get now small change in y by multiplying the value of dy dx times the value of small change in x to give you pi over 90. Therefore, tan 46 is the same as 1 plus pi over 90, which gives you that. And that's what they wanted. So question analysis, the question required candidates to use Maclaurin's theorem in expanding logarithmic expressions. Part B required them to differentiate from first principle. It was an application. So weakness was failure to get higher order derivative. When it came to differentiating second time, third time was a challenge. Converting angles to radians, as long as it is differentiation or integration, angles must be in radians. Teacher should emphasize the use of simpler ways of differentiating, so should look for a simpler method. Then also emphasize differentiation from first principles. So now shall go to question 14. Part A says the point C is the complex plane corresponds to the complex number z, such that this is equal to that. Show that the locus of C is a circle. So the first thing to do is to let the z be equal to x plus yi. Then come and quote the condition and substitute for z. Correct like terms, real alone, imaginary alone, real alone, imaginary alone. Then modulus is given by that 3, then square root of this plus square of this, square root of this squared plus this squared, even here square root of this squared plus this squared. So here we don't put I in the modulus. So expand. What I've done, I've squared both sides to give you this. Then open brackets, inner brackets, open the whole entire brackets, and then collect like terms. So this, since x squared and y squared have the same coefficients and the rest of the terms are linear, it implies that the locus is a circle. That was part A. Part B says find the square root of 5 plus 12i. So let the square root be equal to x plus yi, square both sides, you come up with that, rearrange, then you compare real alone, imaginary alone. So comparing imaginary, there is 12 here, and there is 2xy here, so y is equal to 6 over x. Comparing real alone, there is 5 here, and there is x squared minus y squared here. Then substitute for y to remain with only one unknown, which is x. Rearrange to get a quadratic equation. Then you can solve using the code bulldozer method. So x squared is this, or x squared is this. But x squared cannot be equal to -4. Therefore, x squared is 9. Square root gives you plus or minus 3. Then from equation 1, substitute for x to get the value of y as plus or minus 2. Therefore, square root will be that. And that's what they wanted. So the question required kindness to apply modulus of a complex number and also apply De Moivre's theorem. Weakness was failure to get the modulus of a complex number and failure to find the correct argument. Now, correct argument, this one is for square root. There are two methods for square root for getting nth root, but since it was just square root, I could use the option of equivalence, and that's what I chose to use. But I can also use modulus argument form. Advice to teachers: teachers should emphasize the use of components in finding modulus of a complex number, so don't include the I. Emphasize the right quadrant where the complex number lies when it comes to argument, for those who use an option of argument. Then question 15, the coordinates of P and Q are this and that, respectively. Given that the equation of the line T is this, find the equation of a plane which contains the point P and is perpendicular to the line P. So indirectly, they've given you a point on a plane and the normal vector to the plane. So the direction vector of the line will become the normal vector to the plane. So for this, in vector form, it is that, and this is the direction vector, therefore it should become our normal vector. Then the position vector on the plane is this point P. Then the required equation of the plane can be got by quoting the expression r dot n is equal to n dot p, where r is a variable, x, y, z, n is the normal, and p is a point on a plane. Then dot the two vectors, simplify, and that will be the equation they wanted. That was part A. Part B says, show that the point Q lies on the plane. So you need to get these coordinates and substitute them in the equation of the plane. So when you substitute, we shall come up with this. And it is true because left hand side is equal to right hand side. Part C, determine the coordinates of the point R where the line T intersects with the plane. So intersection of the coordinates of the foot of the perpendicular, we need to get parametric equations. So from that, we have this point, coordinates of point R given in parametric form, x, y, z. Now substitute those coordinates into the equation of the plane. You'll have one unknown, simplify to get the value of that unknown as -1. Now when I substitute this -1 here, I'll be able to get the coordinate of the point they want, which is that, and that's what they wanted in part C. For part D, show that PR and QR are perpendicular. PR and QR are perpendicular. So first get PR, which is OR minus OP. Then also get QR, which is OR minus OQ. Then for perpendicular, dotting should be equal to 0. Then we can conclude that they are perpendicular. And that's what they wanted. So the question required candidates to find the equation of the plane given 2 points and a perpendicular vector. It was not a popular question, so few attempted it, but some failed to obtain the perpendicular vector to the plane. So when they say the line is perpendicular, it means the direction vector of that line is the normal vector to the plane. So emphasize standard form of a line, that is the vector equation, because from it you can easily not see the normal. Then question 16 says the rate at which the quantity M of a commodity is sold is proportional to the difference between the amount initially present and the quantity sold at any time t. Initially, 10 tons of the commodity were present. After 1 day, 2 tons were sold. Part A. Form a differential equation for the quantity of the commodity sold. So they told us the rate at which the quantity M is sold is proportional to the difference between the amount initially present and the quantity sold at any time t. So that means that the MDT is directly proportional to 10, which is initial minus amount sold at time t. So when I put a constant of proportionality, because the value is changing, this one is reducing with increasing time, I'll put a negative constant. Then part B, they're saying determine the expression of M in terms of t and then calculate the quantity sold at the end of 5 years. So here we need to solve the differential equation. It is separable, so separate the variables. Then integrate, this gives this, this gives this. So initially t is 0 and M is 0. Remember, M means what is sold. So M is 0 to get the value of C as negative ln 10. Substitute for negative ln 10 here to give you that. Simplify. Bring this on this side and this on the other side. You'll come up with that. Then from there we can combine these two to give you this division. So after 1 day, M is 2. So we shall substitute T is 1 and M is 2 to give you this. So K is ln 0.8. So substitute for K to give you the particular solution. When I want to remove natural log, I'll put exponential on both sides to give you that. And then I'll make M the subject. And that's what they wanted. Then part B, at the end of 5 years, T is 5, so substitute for T got 5. You'll get this as the amount sold. So the question required candidates to form and solve differential equation, and it was a popular question. Weakness was failure to interpret the question, failure to adhere to the given variables. M and T were supposed to be used. Don't change. Some want to change to X and T. It is not okay. Then failure to solve the differential equation. Teachers advise teachers they should emphasize the use of variables given in the question. Any variable given the question, don't tamper to put your own. Don't tamper to put your own. So general remarks, the questions were from topics of algebra, geometry, trigonometry, analysis, and vectors. So these are the parts where the questions come from. Algebra, there will be 2 section A and 2 section B, Geometry, there will be one section A, one section B. Trigonometry, one section A, one section B. Analysis, 3 section A, 3 section B. Vectors, 1 section A, 1 section B. So in total there will be 8 section A and 8 section B. The performance of candidates in 2024 was poorer. The paper was not well done. It was not done well than that of candidates in the previous year. So there was a decline in the performance. And so that one of the reasons is not going through the paper done in the previous year. So I encourage you to watch and encourage all your fellow candidates also watch this video such that there is an improvement this time round. The quality of work presented was likewise poorer, do you see that, than that of the previous year. So encourage to know the mistakes which was done in 2024 so that you don't do the same mistakes. The paper was a little more difficult than that of the previous year, and the time of 3 hours allocated was adequate. So don't say that time is not enough. The time is always enough. So this was a summary of well done questions, poorly done questions, most attempted questions, and least attempted questions. So 1, you have to choose wisely. So that brings us to the end of this video.